This training is provided by SafeShield. We're a professional training provider that specializes in cybersecurity, compliance, risk management, and AI governance. Our goal is to give professionals the knowledge and skills required to advance their careers and get ahead of the competition. This free course is part of that goal. We want to make trusted, high-quality education accessible and to support the development of responsible practices in new and emerging fields such as AI governance. Welcome to our session on privacy and data protection in AI systems. AI is becoming increasingly integrated into our personal, professional, and societal lives. Whether it's in healthcare, finance, social media, or government services, AI systems often rely on vast quantities of personal and sensitive data. This makes privacy and data protection not only a legal requirement, but also a core ethical responsibility. In this course, we will explore how AI systems collect, process, and use data, and why protecting this information is critical to safeguarding trust, fairness, and human rights. We will begin by defining what privacy and data protection mean in the context of AI. From there, we will examine the risks that emerge when these principles are not respected, such as unauthorized surveillance, data breaches, bias amplification, and loss of individual autonomy. You will also learn about global regulatory frameworks, such as the EU's General Data Protection Regulation, GDPR, the California Consumer Privacy Act, CCPA, and new laws emerging worldwide that specifically address AI systems. By the end of this session, you should understand not only the importance of compliance, but also the strategic advantages organizations gain by respecting privacy. Customers, regulators, and business partners expect AI solutions to be trustworthy, transparent, and accountable. Strong privacy and data protection practices are essential to earning and keeping that trust. Privacy is more than a technical requirement. It is a fundamental human right, recognized globally in laws and constitutions. In the AI context, privacy means giving individuals control over how their personal data is collected, stored, and used. AI systems pose unique challenges to privacy because of the scale, speed, and complexity of data processing. These systems often combine information from multiple sources, sometimes inferring new, highly sensitive insights that go far beyond the original data provided. When privacy is not respected, individuals face risks such as profiling, discrimination, and unauthorized surveillance. For example, an AI model analyzing social media activity can infer political opinions, health conditions, or religious beliefs, often without the person's knowledge or consent. Such uses can have serious consequences, including unfair treatment in employment, insurance, or access to services. From an organizational perspective, weak privacy practices can lead to regulatory penalties, reputational damage, and erosion of customer trust. Today's users are highly aware of their digital rights. They are more likely to engage with businesses that are transparent and respectful in handling their data. Privacy in AI also supports ethical innovation. By embedding strong protections from the start, organizations not only comply with laws, but also strengthen their ability to deploy AI responsibly. In short, respecting privacy in AI systems protects individuals, ensures compliance, and helps build sustainable business value in a data-driven world. Data protection refers to the frameworks, technologies, and practices that safeguard personal data against unauthorized access, misuse, or harm. In AI, data protection goes beyond encryption and access controls. It also involves ensuring that personal data is collected lawfully, processed fairly, and used for clearly defined purposes. These requirements are central to regulations such as GDPR and are equally critical to maintaining trust. AI systems process vast amounts of structured and unstructured data, ranging from customer transactions to sensor readings and voice recordings. The sheer volume and variety of this information create unique protection challenges. For example, anonymizing data in AI can be difficult because advanced algorithms may still re-identify individuals when datasets are combined. Similarly, models trained on personal data may inadvertently memorize sensitive information, risking its leakage and outputs. Data protection also involves respecting individuals' rights. These include the right to be informed, the right to access and correct their data, and the right to have it deleted. In AI, honoring these rights requires designing systems that can trace, manage, and delete personal data upon request, a task that is technically complex but essential for compliance. Strong data protection practices do not slow down innovation. Rather, they enable it. When organizations build AI solutions with privacy and protection at the core, they foster trust, avoid costly breaches, and position themselves as leaders in responsible AI adoption. The consequences of poor privacy and data protection in AI systems can be serious and far-reaching. First, there is the risk of data breaches. AI platforms often store sensitive information in centralized repositories. If improperly secured, these systems can become high-value targets for cyber attacks. Stolen personal data can then be used for identity theft, fraud, or blackmail. Second, inadequate privacy practices can lead to discriminatory outcomes. AI models trained on personal data may inadvertently amplify biases, resulting in unfair treatment in hiring, lending, healthcare, or criminal justice. Such outcomes not only harm individuals, but also expose organizations to regulatory investigations and lawsuits. Third, a lack of transparency about how personal data is collected and used undermines user trust. If people feel that their information is being exploited or shared without their consent, they are less likely to engage with AI-driven services. This erosion of trust can be more damaging than any financial penalty. Finally, organizations face legal and reputational risks. Regulators worldwide are imposing stricter penalties for non-compliance, with fines reaching millions of dollars. At the same time, negative publicity from privacy scandals can damage a brand for years. Addressing these risks requires proactive governance, strong technical safeguards, and a commitment to ethical data practices. Protecting privacy in AI is not optional. It is essential to responsible innovation. To manage privacy and data protection effectively, AI practitioners must be familiar with global regulatory frameworks. The most influential is the European Union's General Data Protection Regulation, GDPR, which sets strict rules on consent, transparency, and individual rights. GDPR has become the benchmark for many other jurisdictions. In the United States, privacy regulations are more fragmented. The California Consumer Privacy Act, CCPA, and the California Privacy Rights Act, CPRA, grant residents significant rights over their data. Other states, including Virginia, Colorado, and Utah, have introduced similar laws. While no single federal law exists, sector-specific regulations like HIPAA in healthcare and GLBA in finance also impact AI systems. Globally, countries such as Brazil, Canada, China, and India are developing or enforcing comprehensive data protection laws. Many of these frameworks share common principles: lawfulness, fairness, purpose limitation, data minimization, and accountability. For AI specifically, new rules are emerging. The European Union's AI Act complements GDPR by imposing obligations on high-risk AI systems, particularly those handling sensitive personal data. Similarly, Canada's Artificial Intelligence and Data Act, IDA, addresses AI governance and accountability. For organizations, keeping track of these evolving frameworks is critical. Compliance ensures not only legal protection, but also competitive advantage. Businesses that demonstrate strong privacy and data governance practices are more likely to earn customer trust and succeed in global markets. To design AI systems that respect privacy, organizations must adopt key principles that guide how data is collected, used, and protected. These principles serve as both ethical guidelines and legal requirements under frameworks like GDPR. The first principle is lawfulness, fairness, and transparency. Data should only be processed when there is a clear legal basis, and individuals must be informed about how their information will be used. Transparency requires plain, accessible communication, not hidden terms buried in lengthy agreements. Second is purpose limitation. Personal data must be collected for a specific, explicit, and legitimate purpose and not repurposed without consent. For AI, this means clearly defining the use case and avoiding function creep, where data collected for one reason is used for another. Third is data minimization. AI developers should limit data collection to only what is necessary for the system to function. Excessive or irrelevant data increases both risk and liability. Fourth is accuracy. AI systems must ensure that personal data remains correct and up to date. Inaccuracies can lead to flawed predictions and unfair outcomes. Fifth is storage limitation. Personal data should not be kept indefinitely. Retention schedules must align with business needs and legal requirements. Finally, integrity and confidentiality. Strong security safeguards must be in place to prevent unauthorized access, leaks, or misuse. Together, these principles build the foundation for trustworthy and compliant AI systems. Two of the most critical principles in AI privacy are data minimization and purpose limitation. Both directly address how much data is collected and how it is used. Data minimization means organizations should only collect the data necessary to achieve the intended purpose of the AI system. For example, if an AI application is designed to recommend music playlists, collecting detailed financial data from users would be unnecessary and inappropriate. Excessive data collection not only increases privacy risks, but also exposes organizations to regulatory scrutiny and penalties. Purpose limitation requires that personal data be used only for the specific purpose originally communicated to the user. If an AI system collects email addresses to deliver personalized product recommendations, those addresses cannot later be used for unrelated marketing without additional consent. In practice, these principles encourage organizations to clearly define the purpose of an AI system at the design stage and to ensure all data collection activities align with that purpose. They also discourage data hoarding, where organizations keep large amounts of personal data simply because it might be useful someday. Respecting minimization and purpose limitation reduces compliance risks, lowers storage costs, and improves overall system security. More importantly, it reassures individuals that their data will not be misused, building trust in AI-driven services. One of the most powerful aspects of modern privacy laws is the recognition of data subject rights. These rights give individuals greater control over how their personal information is used, even in complex AI systems. Key rights include the right to be informed, ensuring individuals know what data is being collected, how it will be processed, and for what purpose. Closely related is the right of access, which allows people to request and review the personal data held about them. Individuals also have the right to rectification, meaning they can correct inaccurate or incomplete information, and the right to erasure, often called the right to be forgotten, which allows them to request deletion of their data under certain conditions. The right to restriction of processing lets individuals limit how their data is used, while the right to data portability allows them to obtain and reuse their personal information across different services. Importantly for AI, there's also the right not to be subject to automated decision-making, including profiling, when such decisions have significant effects on individuals. This ensures human oversight remains part of high-stakes outcomes, such as credit approvals or job applications. Implementing these rights in AI requires technical capabilities like data traceability, deletion mechanisms, and human-in-the-loop review. Respecting them demonstrates a strong commitment to privacy and ethical AI practices. While data subject rights are well established in law, enforcing them in AI systems can be technically and operationally challenging. First, AI models often rely on large, complex datasets that may not be easily traceable to individual records. When someone requests deletion of their data, removing it from training sets or retrain models is not always straightforward. For example, a language model might memorize sensitive details from its training data, making it difficult to guarantee complete erasure. Second, the portability of data is complicated by the diversity of AI system formats. Transferring data in a usable and interoperable way across different platforms requires significant technical coordination. Third, automated decision-making adds complexity. Providing meaningful human oversight requires more than just a token review. It demands clear explanations of how decisions are made, which is difficult in highly opaque models such as deep neural networks. Fourth, organizations often struggle with balancing conflicting obligations. For example, a request for erasure may clash with regulatory requirements for data retention in financial or healthcare records. Finally, implementing these rights requires substantial resources. Smaller organizations may lack the infrastructure or expertise to respond effectively to user requests at scale. Despite these challenges, regulators increasingly expect organizations to provide workable solutions. Building AI systems with data subject rights in mind from the design phase is the most effective way to meet these expectations. Privacy by design and by default is a cornerstone concept in data protection law, particularly under GDPR. It means that privacy safeguards must be built into systems from the outset, not added later as an afterthought. For AI, this principle is critical because of the scale and sensitivity of data processing involved. Privacy by design requires developers to proactively consider how personal data will be protected throughout the AI lifecycle, from collection and storage to model training, deployment, and retirement. This may include techniques like anonymization, encryption, or differential privacy. It also means conducting risk assessments early, identifying potential privacy harms, and embedding safeguards into the architecture. Privacy by default means that the strictest privacy settings should be applied automatically, without requiring the user to adjust settings. For example, an AI-powered fitness app should not share health data with third parties unless the user explicitly consents. These principles encourage organizations to integrate privacy into their development culture. By making privacy a baseline requirement, businesses can reduce regulatory risks, build consumer trust, and create more sustainable AI solutions. In practice, privacy by design and default align with broader ethical AI practices. They push organizations to think critically about data use, ensure accountability, and prioritize individual rights, making AI safer and more trustworthy from the ground up. Two common techniques for protecting privacy in AI systems are anonymization and pseudonymization. While both reduce the risks associated with processing personal data, they serve different purposes and offer varying levels of protection. Anonymization involves removing or altering all identifiable elements of a dataset so that individuals cannot be re-identified, even if the data is combined with other sources. Truly anonymized data is no longer considered personal data under most regulations. However, achieving full anonymization is extremely difficult in practice, especially with AI. Powerful algorithms may still re-identify individuals by linking patterns across datasets. Pseudonymization, on the other hand, replaces direct identifiers like names or ID numbers with artificial identifiers, such as codes or tokens. Unlike anonymization, pseudonymized data can still be relinked to an individual if the key or mapping is available. While pseudonymized data remains subject to privacy laws, it significantly reduces risk and supports safer processing. For AI, these techniques are critical in both training and deployment. They enable organizations to analyze large datasets while minimizing exposure of personal information. Yet they're not foolproof. Organizations must combine them with strong governance, access controls, and regular reevaluations of re-identification risks. In short, anonymization and pseudonymization are valuable tools but should be seen as part of a layered privacy strategy, not standalone solutions. While anonymization is often presented as the gold standard of privacy protection, its effectiveness in AI systems has clear limitations. AI models are exceptionally good at identifying patterns, even in data that has been stripped of direct identifiers. For example, an anonymized health dataset may exclude names and addresses, yet still contain unique combinations of age, postal code, and diagnosis that allow re-identification when matched with publicly available records. This risk increases as more datasets are combined. Another limitation is the persistence of data in trained models. Even if the original dataset is anonymized, machine learning models may memorize unique characteristics or outliers that indirectly point back to individuals. This phenomenon undermines the assumption that anonymization eliminates all risk. Regulators also recognize these limits. Under GDPR, data is only considered fully anonymized if re-identification is reasonably impossible. In practice, this is an extremely high bar. Most real-world datasets fall short of this threshold. Therefore, organizations should treat anonymization as risk reduction, not risk elimination. Complementary techniques, such as differential privacy or federated learning, provide stronger guarantees by adding statistical noise or keeping data localized. Ultimately, the goal is not to rely solely on anonymization, but to combine technical safeguards with organizational policies and ethical oversight. By doing so, AI developers can more effectively manage the inherent risks of working with personal data. One of the most overlooked aspects of privacy compliance is how long personal data is retained in AI systems. Data retention and deletion policies are essential to ensure compliance with privacy laws and to minimize unnecessary risk. Retention should be based on a clear legal or business need. For instance, customer data used for billing may need to be retained for a fixed number of years under financial regulations. Beyond that period, keeping the data serves no legitimate purpose and only increases exposure to breaches. In AI, retention challenges are amplified. Data may exist in multiple forms: raw training datasets, pre-processed versions, feature sets, and even within trained models. When an individual exercises their right to erasure, organizations must ensure that all instances of their personal data are identified and deleted. This may require retraining models or implementing techniques like machine unlearning. Equally important is defining retention periods at the design stage. AI systems should include built-in mechanisms to enforce automatic deletion once data is no longer needed. Logging and documentation are critical to demonstrate compliance to regulators. Failure to manage retention properly exposes organizations to fines, reputational harm, and erosion of trust. Conversely, well-defined policies reduce storage costs, simplify compliance, and show respect for user rights. Strong security measures are a cornerstone of data protection in AI systems. Because AI often processes sensitive personal information, security failures can have devastating impacts on both individuals and organizations. The first layer of defense is access control. Only authorized personnel should have access to datasets, models, or system outputs. Role-based access and multi-factor authentication are essential to prevent unauthorized use. Second, encryption should be applied both at rest and in transit. This ensures that even if data is intercepted or stolen, it remains unreadable to outsiders. Third, organizations must implement robust monitoring and logging. Continuous oversight of data access, model queries, and system activity can detect anomalies and potential breaches early. Fourth, techniques like differential privacy and federated learning enhance security by reducing the exposure of raw data. In federated learning, data remains on local devices and only model updates are shared, minimizing centralized risks. Finally, regular vulnerability assessments and penetration testing are essential. AI systems are evolving targets, and proactive testing helps identify weaknesses before attackers exploit them. These measures must be supported by policies, staff training, and an incident response plan. Effective security is not only about technology, but also about organizational readiness. Together, They create a strong defense against privacy violations and cyber threats. Accountability is central to privacy and data protection in AI systems. It means that organizations are not only responsible for complying with laws, but must also be able to demonstrate that compliance. This begins with clear governance structures. Roles and responsibilities for data protection should be explicitly defined. A data protection officer, DPO, or equivalent role is often required under laws like GDPR, ensuring oversight and independence. Organizations should maintain detailed records of processing activities. These logs document what data is collected, why it is used, how long it is retained, and what safeguards are applied. In AI, this extends to model training data, algorithm selection, and evaluation methods. Another key aspect is conducting data protection impact assessments, DPIAs. For high-risk AI applications, such as biometric identification or automated decision-making, a DPIA is legally required in many jurisdictions. It ensures risks are identified, mitigated, and documented before deployment. Accountability also requires mechanisms for redress and complaints. Individuals must have clear pathways to challenge how their data is used or to seek correction when rights are violated. Finally, accountability is cultural as much as procedural. Organizations that embed privacy into their values and operations are better positioned to innovate responsibly. By demonstrating accountability, they earn the trust of users, regulators, and business partners alike. A data protection impact assessment, DPIA, is a structured process to identify and minimize privacy risks before deploying an AI system. Under GDPR, DPIs are mandatory for high-risk processing activities, which often includes AI systems that involve profiling, sensitive data, or automated decision-making. For AI, a DPIA begins with a clear description of a system, including its purpose, data flows, and decision-making logic. Next, organizations must identify potential risks to individuals' privacy, such as excessive data collection, bias, or the inability to honor deletion requests. Mitigation measures are then defined. These may include technical safeguards like encryption or differential privacy, as well as organizational steps like restricting data access or establishing human oversight. The DPIA should also evaluate whether the system complies with relevant legal and ethical standards. Documentation is essential. Regulators may request DPIAs as evidence of compliance, and auditors use them to verify that risks were properly assessed. In addition, DPIAs provide transparency to stakeholders and can strengthen public trust in AI projects. Conducting a DPIA is not just a legal checkbox. It is a proactive risk management tool that helps organizations detect issues early, reduce liability, and align AI innovation with responsible practices. Done well, it becomes a valuable blueprint for balancing innovation with individual rights. AI systems often operate globally, processing data across borders. This creates significant challenges for privacy and data protection, since different jurisdictions impose different rules on international data transfers. The European Union, under GDPR, restricts transfers of personal data to countries without adequate protections. To bridge this, mechanisms like standard contractual clauses, SCCs, or the EU-US Data Privacy Framework are commonly used. These tools establish contractual obligations to ensure data is safeguarded once transferred. Other jurisdictions, such as Brazil and Canada, follow similar adequacy or contractual models. Meanwhile, China imposes strict localization rules, requiring certain categories of personal data to remain within national borders. For AI, cross-border transfers are especially complex. Training models often requires pooling global datasets, and cloud-based AI services may automatically move data between regions. Organizations must map where data travels, identify applicable legal requirements, and implement safeguards accordingly. Technical measures can support compliance, such as encryption during transfer and anonymization before export. However, legal agreements and regulatory approvals remain essential. Managing cross-border transfers is not only about compliance, but also about reputation. Users expect their data to be handled responsibly, regardless of geography. Transparent practices reassure stakeholders that global AI systems respect local privacy rights. Certain types of personal data are considered especially sensitive and are subject to stricter protections under laws like GDPR. In the AI context, handling these special categories of data requires particular care. Examples include data revealing racial or ethnic origin, political opinions, religious beliefs, trade union membership, genetic and biometric data, health information, and details about sexual orientation. Processing such data without strong safeguards can expose individuals to serious risks, such as discrimination or stigmatization. AI applications frequently engage with these categories, often indirectly. For instance, biometric data is central to facial recognition systems, while health data powers diagnostic AI tools. Even data not explicitly labeled as sensitive may become so when combined with other sources, creating inferred attributes such as pregnancy status or political leanings. Regulations typically prohibit processing special categories unless specific exceptions apply. These include explicit consent, substantial public interest, or medical necessity under professional confidentiality. For AI developers, this means rigorous assessment of whether such data is essential, whether less invasive alternatives exist, and what safeguards are in place. Strong anonymization, encryption, and access controls are critical. Ultimately, organizations must treat sensitive data with heightened responsibility. Respecting these protections not only ensures legal compliance, but also reflects a commitment to fairness and respect for human dignity. Protecting children's data is a top priority in privacy regulation, and AI systems must take particular care when processing it. Children are considered more vulnerable because they may not fully understand how their data is used or the risks involved. Under GDPR, the processing of children's personal data requires parental consent in most cases when offering online services. The exact age threshold varies by country, but typically ranges between 13 and 16 years. Similar protections exist in other jurisdictions, such as the U.S. Children's Online Privacy Protection Act, COPPA. For AI, children's data is often present in contexts like educational apps, gaming platforms, and social media. These systems can involve behavioral profiling, targeted advertising, or automated recommendations, all of which must be designed with strict safeguards. Key measures include obtaining verifiable consent, providing age-appropriate privacy notices, and avoiding manipulative practices such as nudging children into oversharing. Developers should also implement data minimization, collecting only what is necessary, and strong default privacy settings. AI systems should never exploit children's data for unfair commercial gain or expose them to harmful content. Regulators take violations in this area extremely seriously, with fines and enforcement actions being common. Protecting children's privacy is not only a legal duty, but also a moral responsibility. AI developers must place the welfare and rights of young users at the center of system design and operation. Consent is one of the most widely recognized bases for lawful data processing, but in AI systems is often misunderstood or poorly implemented. For consent to be valid, it must be freely given, specific, informed, and unambiguous. This means users must clearly understand what data will be collected, how it will be used, and for what purpose. Pre-ticked boxes, vague language, or bundle consents do not meet this standard under laws like GDPR. AI adds complexity because data use may extend far beyond the initial purpose. For example, training a recommendation engine might require using browsing data in ways not easily explained to users. In such cases, organizations must balance transparency with simplicity, ensuring individuals genuinely understand their choices. Another issue is power imbalance. If refusing consent means losing access to essential services, regulators may consider the consent invalid. This is especially relevant when AI is embedded in education, healthcare, or employment systems. Consent must also be revocable. Users should be able to withdraw it at any time, and systems must be designed to honor this by stopping or deleting data processing promptly. While consent is a valuable tool, it should not be over-relied upon. In many cases, other legal bases such as contractual necessity, legitimate interests, or public interest may be more appropriate. The key is to ensure consent, when used, is genuine, meaningful, and respected in practice. Transparency and explainability are not just technical requirements in AI. They are also privacy safeguards. If individuals do not understand how their data is being processed, they cannot meaningfully exercise their rights or give valid consent. Transparency means being clear and open about what data is collected, why it is needed, how it will be used, and who will have access. This includes privacy notices, terms of service, and user interfaces that are written in plain, accessible language. For AI, transparency must also cover aspects of automated decision-making and profiling. Explainability goes further. It ensures that users and regulators can understand the logic behind AI-driven outcomes. For example, if a loan application is denied based on an algorithm, the applicant has a right to know which factors influence that decision. Without explainability, the right to challenge automated decisions becomes meaningless. Achieving explainability in complex AI models can be difficult. Black box systems like deep neural networks are notoriously opaque. To address this, organizations are increasingly using techniques such as model interpretability tools, surrogate models, and feature importance analyses. By embedding transparency and explainability, organizations not only meet legal obligations, but also build trust. Individuals are far more likely to share data and engage with AI-driven services when they feel confident that processes are understandable, fair, and accountable. Privacy in AI is not only a matter of legal compliance, but also of ethical responsibility. AI systems often touch the most personal aspects of people's lives: health, employment, education, and social interactions. As such, respecting privacy is integral to respecting human dignity. Ethical considerations begin with recognizing the power imbalance between individuals and organizations. AI systems can infer highly sensitive insights from seemingly trivial data. Ethically, organizations must ask not only can we do this, but also should we do this? Key ethical principles include fairness, ensuring AI does not amplify bias or discrimination; autonomy, respecting individuals' control over their personal information; and accountability, making sure there are clear lines of responsibility for data handling. Another consideration is proportionality. Even if data collection is legally permitted, is it proportionate to the purpose? For example, collecting detailed biometric data for a basic login feature may be disproportionate and unnecessary. Ethics also demand that vulnerable groups, such as children, minorities, or economically disadvantaged individuals, receive heightened protection. Exploiting their data for profit or surveillance undermines social trust. Embedding ethics into AI privacy practices goes beyond compliance checklists. It reflects a commitment to building technology that serves people responsibly, ensuring that innovation does not come at the cost of fundamental rights. To address the challenges of privacy in AI, researchers and practitioners have developed a range of privacy-preserving techniques. These methods enable organizations to extract value from data while reducing risks to individuals. Differential privacy adds carefully calibrated statistical noise to data or outputs, making it difficult to trace results back to any individual while still allowing useful analysis. This technique is widely adopted by companies like Apple and Google. Federated learning allows AI models to be trained across multiple decentralized devices or servers without transferring raw data to a central location. Instead, only model updates are shared, reducing exposure of personal data. Homomorphic encryption enables computations to be performed on encrypted data without decrypting it first. While computationally intensive, it offers strong protection for highly sensitive use cases. Synthetic data is another option. By generating artificial datasets that mimic real data, organizations can test or train models without exposing actual personal information. These techniques are not silver bullets. Each has trade-offs in terms of complexity, performance, and effectiveness. However, when combined with strong governance and legal compliance, they represent powerful tools for building AI systems that respect privacy while still enabling innovation. Regulators and oversight bodies play a critical role in ensuring privacy and data protection in AI systems. Their mission is to enforce compliance, provide guidance, and protect individuals from misuse of their personal data. At the international level, organizations like the European Data Protection Board, EDPB, issue interpretations of GDPR and coordinate enforcement across EU member states. In the US, bodies such as the Federal Trade Commission, FTC, oversee consumer privacy protections, while state regulators enforce local laws like CCPA. Specialized regulators also exist for certain sectors. For example, healthcare data may fall under HIPAA enforcement, while financial data is overseen by banking regulators. Increasingly, regulators are focusing on AI-specific risks, such as automated decision-making and biometric surveillance. Oversight is not limited to penalties. Regulators often provide guidelines, codes of conduct, and certification schemes to help organizations implement best practices. For instance, some data protection authorities publish templates for DPIAs tailored to AI systems. The role of regulators extends to public trust. Effective oversight assures individuals that their rights are protected and that organizations cannot act with impunity. For businesses, proactive engagement with regulators can prevent costly disputes and position them as leaders in responsible AI. Strong privacy and data protection in AI systems require more than policies and technology. They depend on organizational culture. Everyone involved in designing, deploying, or using AI must understand their role in safeguarding personal data. This begins with leadership. Executives must set the tone by prioritizing privacy as a strategic value, not just a compliance obligation. Appointing roles such as a data protection officer, DPO, signals accountability and ensures dedicated oversight. Training is equally important. Employees who handle data should be educated on topics like lawful processing, minimizing collection, handling deletion requests, and responding to breaches. For AI developers, training should cover privacy-preserving techniques, ethical principles, and emerging legal requirements. Culture also means integrating privacy into daily operations. This includes clear escalation paths for reporting privacy concerns, rewarding teams for responsible practices, and embedding privacy into design methodologies like Agile or DevOps. Organizations that cultivate a strong privacy culture benefit from reduced risk, improved compliance, and enhanced trust with customers and partners. Most importantly, they create AI systems that reflect respect for individual rights, ensuring technology works in service of society rather than against it. The field of AI privacy and data protection is rapidly evolving, shaped by technological advances, regulatory reforms, and shifting public expectations. One of the most significant trends is the rise of AI-specific legislation, such as the EU AI Act and Canada's IDA, which complement existing data protection laws by addressing risks unique to AI systems. Another trend is the growing use of privacy-enhancing technologies, PETs. Differential privacy, federated learning, and synthetic data are moving from research labs into mainstream deployment, enabling organizations to innovate while respecting user rights. We also see increasing emphasis on algorithmic transparency. Regulators and stakeholders expect organizations to provide clear documentation of data sources, model behavior, and decision-making logic. Explainability is becoming not just a best practice, but a regulatory requirement. At the same time, consumer awareness of digital rights is expanding. Individuals are more likely to demand control over their personal data, challenge automated decisions, and hold companies accountable for misuse. Finally, AI developers are recognizing the need for global harmonization. With regulations differing across jurisdictions, organizations must adopt flexible frameworks that align with multiple standards. These trends highlight a clear reality. Privacy and data protection are no longer optional add-ons. They are integral to the future of AI. Organizations that embrace them proactively will be better positioned to build trust, comply with laws, and maintain a competitive edge. Learning from real-world failures provides valuable insight into the consequences of neglecting privacy in AI systems. One notable case involved a facial recognition startup that scraped billions of images from social media without consent to build its AI database. Regulators ruled the practice unlawful, leading to lawsuits, fines, and widespread criticism. The company's reputation suffered irreparably. Another example comes from healthcare. An AI tool designed to predict patient needs was found to be biased because it used healthcare spending as a proxy for health. As a result, minority patients received systematically lower scores, limiting their access to care. Beyond the ethical harm, the organization faced regulatory scrutiny for improper handling of sensitive health data. A third case involved a large technology company that recorded and analyzed children's voices through a virtual assistant without adequate parental consent. Regulators imposed multi-million-dollar fines, citing violations of children's privacy rights. These failures share common themes: lack of transparency, overcollection of data, inadequate safeguards, and failure to respect individual rights. They serve as reminders that privacy lapses in AI are not abstract risks, but real events with legal, financial, and ethical consequences. By studying these cases, organizations can better anticipate risks and design AI systems that prioritize accountability and trustworthiness from start. As we conclude this session on privacy and data protection in AI systems, let's reflect on the key lessons. First, privacy is not just a regulatory box to tick. It is a fundamental human right and a foundation for trust in AI systems. Protecting it requires embedding principles such as lawfulness, fairness, transparency, data minimization, and accountability throughout the AI lifecycle. Second, individuals must remain at the center. Recognizing and enabling data subject rights, access, erasure, portability, and freedom from harmful automated decisions is critical for both compliance and ethical responsibility. Third, technical measures matter. Techniques like anonymization, differential privacy, and federated learning reduce risks, but they must be supported by strong governance, culture, and oversight. Fourth, regulators worldwide are raising expectations. Noncompliance leads to fines, reputational harm, and loss of user trust. Proactive engagement with laws and ethical frameworks positions organizations as responsible innovators. Finally, the future of AI lies in balancing innovation with protection. By respecting privacy and safeguarding data, organizations can develop AI systems that are not only powerful, but also trustworthy, fair, and aligned with societal values. Thank you for engaging in this learning session. The responsibility now rests with you to apply these principles in practice, ensuring that AI serves humanity responsibly while upholding the rights and dignity of every individual. This knowledge provides you with a strong foundation to aid you in the future, whether you apply it in your current role, pursue further study, or contribute to shaping responsible AI in your organization. By staying informed and engaged, you will play a vital role in ensuring AI develops in ways that are safe, ethical, and beneficial for society. Thank you for your time and your commitment to this learning journey. We encourage you to keep exploring and keep building toward a future where artificial intelligence serves the needs of humanity responsibly.